Hey everyone, it is me again. This is a very exciting episode. This shit has taken me like 5 days to a week to get this to finally actually work functionally in real life, which has been, a huge challenge, but hey, it's not any fun if it's not a challenge. So yes, but I've finally done it. And after many prototypes, here it is. This is the model. I am going to be showing you the real life version in a few minutes. So don't click away yet. We're not staying on the computer for the whole episode. So yeah, I will show you the real life version in a minute. Pretty much everything with this gear blade is almost sorted now. There is only one tiny little thing that I need to do to this now to make it, 100% perfect. But I'm going to save that for the final video, or the final episode, I guess you could call it. This is the final episode of me showing you how it works and the design and the build. And the episode after this, or the video after this, is going to be the final project, the final product video, sorry. So I'm going to be showing it in action, showing it working, all that kind of stuff. Stabbing some things, testing underwater, that kind of stuff. So yeah, that's in the next video when it's all completely finished, just after those minor changes I got to do. But in terms of locking system, it is now fully functional and it locks every time, which is amazing. Okay, so I just want to show you what I did to actually get this to work. So obviously, if you are following the last locking episode I did, I would have shown you this slider system here. Now there is a few changes I had to actually make to get it to work. So as some of you suggested, extending the tail bit, which I did do, but I also added a tiny 0.25 mil raise on that back tail, as you can see there. So you can see how it comes up a little bit. So the reason why I had to add that in is because if you can see the distance here between the lock tab and the base hole, so if we look here, you see how the hole is bigger than the actual tab. Now, if you're familiar with 3D printing, you'll know that I've done that because of tolerances you need to follow with 3D printing. So what I've found is that 3D printed parts generally work out to be 0.2 bigger than what they actually are on the computer. So, and that can just be due to, expansion of the plastic, or the extrusion ratio, extrusion multiplier you have set on your printer, and just the overall calibration and the quality of your printer as well. So, but I found in my studies, in my testing, that typically if you leave a 0.25 mil tolerance between the parts, especially on moving parts like this blade here, then you should have enough room for it to move freely without being stuck or having too much friction. So you can see I've got that little gap in there, and that is obviously so that this lock tab can move. Now, the reason why they gave me an issue with the locking was because when this slider tab moved to push the lock out the way, because that little ramp wasn't there initially, it would actually push the whole lock system down. So you can see that gap there, it would actually push this down. And that would mean that it wouldn't pull the lock tab in completely, so it would end up sticking out probably about that much. And that was just enough to cause the blade to catch on there like that every couple of tries. So obviously we can't have that if we want the blade to function 100% of the time. You can't have it catching on the lock tab when it's supposed to move in and out. So what I did is, like I said before, I added this little ramp piece there, and that just means that as soon as this hits it, it's going to well and truly move it out the way, so that when this goes past, as you can see, it's obviously in there, but there's some room up there for it to move, then the blade will definitely slide without any dramas there. So that is what I did to the lock tab. Now, I found another issue was that on my slider piece, if I orientate you here, you can see obviously we have that little piece that sticks up that it was attaching to the elastics before. Now, I changed that design as well. Instead of this attaching to the elastics in the top piece, I actually made it attach to the, if we get rid of this, hang on a second. I actually made it attached to the loop in the string. So the elastics loop around this one, and then the loop in the string that attaches to the elastics actually goes over this as well, so that even the finest movement of the string will pull the sliding piece, and that way it's 100% going to move the lock tab out the way before the gears kick in. Because what I found was that when this was attached to the elastics instead of the string, sometimes the elastics wouldn't stretch, will provide enough tension on the lock tab to make it move. So the gears were activating before the lock tab had a chance to move out the way, and that caused the whole system to essentially fail because the gears were biting against the lock tab, and then the whole thing would just jam up and it wouldn't move at all. So that's why I opted to put this on the string instead of the elastics, and now it works perfectly. So you only really need like 2 mils of movement here for that lock tab to be fully disengaged down here. So that's what I wanted, because it had to disengage the lock before the wheel started spinning, because obviously that means that the gears will start spinning as well. So the tiniest bit of movement, lock tab disengages, which is perfect. The other thing I did was I also extended the track, because originally this only slid to around here. But what I found was that the string needed some more room to be pulled in order to get the wheel to rotate a full 180 degrees. And what was happening was, because that was stopping here, too much tension was being pulled on this little piece, and that caused it to snap off of the slider. So what I did was increase this by 4 mil, so you can see now it can slide all the way back to here. That way there is no tension on this little piece there, and it would no longer snap off. So that was the other thing I changed as well. And obviously with doing that, that drove me into some other issues. The main issue being I forgot to expand the track on the base piece here. So what was happening is it was hitting that, even though it still had to move another 4 mil, but it was hitting the wall here. So I just offset that wall another 4 mil there, and I offset this wall another 4 mil. So now it can move that complete amount. And then the last issue I faced was that this piece, because it had moved so far back now, there was no way that I could make it stay within the railing here. So then it was free floating around in here, and obviously you can't have it get in the way of the blade. So what I did is added this angled piece there, or this sloped piece. And essentially that means that even if this was to move down, which it shouldn't because that is holding it straight, that sloped piece will guide it back into the track there. So it should work perfectly. And instead of the elastic design, which I had here originally, I've put a channel in there that I put a piece of spring wire. So instead, that spring wire pushes the lock tab out, which I will show you in real life. But yeah, that is pretty much everything I have done to the lock system. So now this lock system is fully operational, works 100%, and I'm going to show you that in real life now. But yeah, there is only one more change I need to make, and that is to add a guide system for the blade now. So obviously, because we have room in here, you can see when the blade gets to this point, right here, you can see now there is no wall touching the blade on this side. So what that means is the blade can actually move a little bit, and if it moves enough, what ends up happening is it will stick in this corner here. So you can see I tried to do chamfer that to get rid of that issue, but occasionally on the way back out, this corner will actually hit that corner because the blade is moving in that track, and it will hit there. So really, really easy fix. I'm just going to cut out a little piece there, and then I will put a rail in the bottom of this gear piece right here, and that will keep it straight the whole way in the channel. So that will fix that issue. And lastly, the only other thing I'm going to do is, as one of my subscribers suggested, was a bearing system, which I think is a brilliant idea, especially for gears like this. So obviously in the product video I showed, well, in the one of the other episodes where we had the model out, you could tell that it was a little bit noisy, and that's mainly the rattle of the plastic spinning on each other here. So what I've actually done is gone and got some really, really small bearings, and we're going to replace these with steel pins and put bearings inside of the gears. So that should completely, well, make it a lot more silent, and it will make it a lot smoother as well. But as a proof of concept at the moment, this thing works perfectly. So yeah, let's get on to the real life showing now. Alright, here we go. So I haven't put in all the screws because I am going to take this apart and show you the inside of it, and I don't want to obviously have to spend all my time unscrewing this whole thing.
But yes, this is really like the proof of concept. So as I showed you on the computer just a second ago, the lock tab is now installed in this, the locking system. So not only have we got the gear drive going, we also have the lock system going. So now this thing is an absolute beast of a piece of engineering work. Like, the amount of design and concept that has gone into this is just phenomenal. Like, I still can't believe I actually managed to do this. Initially when I thought of this project, I thought it would just be super easy, slap a few gears in there and away we go. But yeah, if you want something to be functional and to actually work properly and be usable, then yeah, you gotta put your brain to it. So as we say, reference to PewDiePie, big brain. But yeah, here we go. So all I need to do is chuck these bearings in. So I've got these really tiny little bearings. As you can see right there, they're really, really small. So all I'm going to do is throw these bearings in to all the gears, and then we just have to attach a track for the blade as well, just to keep it straight in there because it has that little bit more room and we don't want it to catch on the lock system at all. And then that will be it. Final project video will be coming out. So enough talk, and let's see this thing in action. Here we go. Boom. Boom. Now, when this comes out, like I said before, it is now locked. So you can see before there was quite a bit of wiggle room in there, and now there is none. There is no wiggle room in that at all. So I'm not going to show you me stabbing anything with it in this video because obviously I want to save that for the final project video with the bearings and everything in there when it's fully complete. But yeah, you can see this is locked in place, and then what happens as soon as we pull the string again, comes back in. No issues, no catching, no friction, no nothing. It's just perfect. So perfect, look at that. So yeah guys, really, really happy with this. Obviously this has taken so much time, but fully locked, just like that, fully locked in place, and obviously doesn't come out either, just like that. So yeah, really, really cool. Alright, I'm going to quickly disassemble this and you guys can have a little bit of look of what's going on in here, and yeah, I'll cut to that. Okay, so I've just removed the very top cover so you can see this in action a little bit, so I'm going to zoom you in. Alright, here we go. I'm trying to think of the best way to show this. So you can see obviously we have the Almond Ra wheel there. Then we have my rack and pinion system and my whole gearbox there. So I'm going to show you just a little bit of what's actually happening in this thing. See, if we pull this, comes out, comes back in. Just like that. So obviously you need the top cover on for it to be perfect, but really, really, really cool. So then what we do is we take this piece off. I find my tweezers, there we go. So we take this out. You can see there we have the bar, the connector bar with the rail gear there. So yeah, looks pretty cool. Then we'll go ahead and take these screws out. Okay, so I've now removed all the screws from the top case, so we can actually take this off now. Alright, so we look in the top case, there is the guide piece there, so that actually goes into that first gear at the front, so it just has a little bit more support and strength. Okay, now this is actually the main systems. This is what makes everything really work. Obviously this is my gear design. The wheel back here has a screw set in the middle so that it keeps it in the guide channel. Now this is what I was talking about with that little slider piece. So I don't think I can zoom you in any more than that, but if we take the elastic off, okay, now the string is off, just like that. I'll spin this around, hopefully you can see a little better. Okay, cool. Alright, so you can see this piece here, that is where the elastic sits on, and then this little bit back there is where the actual loop of the string. So if you can see on the string there, there's that loop where the elastic sits, that little loop there. That's what goes over this little piece. And then that piece is what engages and disengages the lock when it slides back and forth. So obviously as you pull the string, pulls it back, that's disengaged the lock, and then when the string resets, it will just pull it back forwards again, just like that. So you can see that moves there within that track, nice and easily. Alright, and then I'm just going to take out that first gear. You can see obviously that's how the gears work there. That spins around, and then if we put this front one in like that, you can see this would obviously push your blade in and out like that. So cool, and then we take this off. Alright, so that's your gearbox there. Now here is the blade and the lock system. So really cool here. So this is obviously the blade and it slides within this channel. And then up the front right here is our lock tab. So you can see that's spring loaded like that. And then what essentially happens is this is pushed out the way. So if I just hold that there, you can see as I slide this piece, that lock's engaging and disengaging. I don't even know if you can see that, but hopefully you can. I'll just put my finger on there. So there's the slider, pull that in, lock disengages, just like that. Cool. Alright, so if I slide the blade out, bam, you can see now that that is locked in place there. I can't push it in. And then what happens when we pull the slider here, pulls it in, and now the blade can slide back in. Now what I was talking about before is you can see that because the railing needs a place to run through here, you can see that blade wiggles a little bit in this section, so that can cause it to get caught on the sliding pin there. So that's what I was saying before, I need to put a railing or a track essentially underneath this gearbox, and it will sit in that channel here that the gears use, and that way it will keep it straight the whole time. And then all we really have to do is put the bearings in there, and then that should be it working perfectly. And yeah guys, that's pretty much it. The next challenge will be making this dual extended. I've already got a design for that, super easy. I got the idea from telescopic sliders. So if you know how telescopic mechanisms work, then you'll know how I'm going to make the dual extended blade to this. But if you don't, go have a look and it should give you a pretty good idea. But yeah, I'm going to show you me wearing this just for a little bit so you can see how it works on the arm. And then that'll be it till the final video of this project, which will be pretty exciting. But yeah, we got the Valhalla blade, we got some really dope projects coming up soon. I am restocking the hidden blades, I'm just waiting on some materials at the moment. So thank you for everyone for being real patient. I promise you they are coming out again. We just, got to wait on some materials unfortunately, and due to coronavirus and everything it's taking a little bit longer than usual. But I'm hoping to have everything within 6 to 7 days. But yeah guys, that's it for today's video. Hope you enjoyed. Leave a like, comment, subscribe if you did. And yeah guys, I'll see you in the next video. Alright, this is all you guys are getting. You're going to have to wait for the final video before I show you the stabbing test and all that stuff, and to make sure the lock's all good, but this is all you're going to get for now. So you can see when it comes out, fully locked in place, will not go back in. But yeah, locks every time, comes back in. Awesome.